Almost everything a computer does today is a workload, a web app, a database, a nightly batch job, and now the heaviest one, an AI model running on a rack of GPUs. A workload is software you need to keep running. It has become the thing modern computing is built around. The real question is who keeps your workloads running. Whatever the workload, you want the same four things: keep it alive, survive a machine dying, add copies when traffic spikes, ship new versions without downtime. Everything after this is about who does those four and how much of it you do by hand. The simplest answer is one server. Rent a machine, put the app on it, done. It works until the machine dies or traffic doubles or you push a bad build. One box gives you none of the four. You need many machines acting as one and something to wire that up. On AWS, you do it yourself. An auto-scaling group keeps 5 copies alive and adds more under load. An elastic load balancer sits out front. Health checks replace sick instances. A baked machine image holds your app. CloudWatch alarms trigger the scaling. Secrets live in Systems Manager. Code Deploy rolls out versions. Wire it together, and it runs. Look at what you built. Not an app, a pile of separate services, each set up by hand, glued together, that you now own. It doesn't understand your app. It knows the exact steps you scripted and nothing else. You gave it steps, not a goal. Launch this, attach that, alarm on this. When something drifts out of place, nothing pulls it back. A bad version ships, and rolling back is you, at 3 a.m., swapping machine images by hand. The self-healing is only what you remembered to build. Every piece is AWS only, auto-scaling groups, ELB, AMIs, those names exist nowhere else. On Google you rebuild it with different parts. On Azure, again, run some of it in your own data center, and now you're gluing clouds together by hand. That was one service on one cloud of one kind. Real systems have 20 services. Some are stateless web apps, some are databases that can't just move, some are batch jobs, some are GPUs training a model. Each type needs different glue. 20 services across 4 clouds across every type, and then you run it for years, patching, scaling, securing, upgrading. Each of those needs its own glue, and the amount of it multiplies until no one can manage it. Stop scripting steps. Write down the end state you want, run 5 copies of this, keep them healthy, update them this way, and hand it to something whose only job is to make reality match that description on any cloud. That shift from steps to desired state is workload abstraction. It is what Kubernetes is. It starts with one unit of work. You package the app and everything it needs into a container, a sealed box that runs the same on any machine, any cloud, any type. Web app, database, batch job, AI model, all just containers now. You hand Kubernetes a few lines called a deployment. Run 5 replicas of this image. Update them with a rolling strategy. Here is how to check one is alive. Notice what's missing. No machine name, no launch steps, no load balancer wiring. You stated what should be true, not how. Behind it runs a loop that never stops. It compares what you asked for to what is running. Wanted 5, sees 4. It starts 1. A machine dies. It moves the missing copies to healthy machines. You wrote none of that. It is what the abstraction does. The self, healing your alarms, and scripts were doing by hand, now built in. The rest of the pile collapses into it. A service replaces the load balancer, one stable address that spreads traffic across healthy copies. Ingress replaces the edge routing. A horizontal pod autoscaler replaces the CloudWatch and scaling group setup. Config maps and secrets replace Systems Manager. 10 consoles become one way to say things. Once a whole company describes its workloads the same way, the cluster becomes a shared platform. Dozens of teams on one cluster, each walled into a namespace. Each with a quota so nobody starves the rest, all governed by RBAC. You write policy once and it is enforced on everything that lands, network policies for what may talk to what, and admission controllers, OPA gatekeeper, Caverno, that reject anything insecure before it runs. Because you describe the workload and not the cloud, the same files run on AWS, on Google, on Azure, and on your own racks, hybrid and multi-cloud, the same everywhere. Kubernetes talks to each one underneath. Your description does not change. Your teams, policies, and workloads move with you. You stopped rebuilding your system once per vendor. Pointed at AI. Training a model is a workload too, spread over hundreds of GPUs that each cost more than a car. Kubernetes treats a GPU as one more resource to schedule. It packs them so none sit idle. It schedules a distributed training job so all its pieces land together. It auto-scales the finished model's copies with demand. It's the same idea, describe the workload applied to GPUs. Side by side, before the hand-built AWS pile one cloud, one service that broke on a bad release. After a few files, self-healing and portable and multi-tenant, running web apps and databases and GPUs the same way across every cloud. The catch is real. Kubernetes is complex, and now you run the cluster too. For a single small service, a managed runner, Fargate, Cloud Run, container apps, is simpler, and you should use it. Kubernetes earns its cost when you have many workloads, many clouds, and years of operating them ahead. Kubernetes was never about servers. It is a layer that turns the exact steps to run one thing on one cloud into a description of the workloads you want. You say what should be true. A loop keeps it true, across every type, every service, every cloud, without you.